That's the end of the electromagnetic spectrum. Next, sound and ultrasound waves. Sound and ultrasound waves are caused by vibrations in particles of matter, solids, liquids and gases. Sound waves are only transmitted through matter and cannot travel through a vacuum. As you watch the next clips, make a note of how sound waves behave.
So what is sound? It's produced by vibrating objects. Can you hear that? All matter is made of particles. As the ruler bends forward, it pushes particles in the air closer together. This makes a region known as compression, which moves forward like a stack of dominoes pushed over. As the ruler moves backwards, the particles in the air move further apart, making a region called rarefaction. The ruler moves forward again, making another compression, which forces the rarefaction and first compression forwards. In this way, compressions and rarefactions move out from the ruler, making a sound wave. But it's not just a noise that we hear. We can hear if a sound is low or high, low-pitched or high-pitched. The pitch of a sound is determined by the number of vibrations produced in a second. That rate, or frequency, with which sound waves are produced is very important. The higher the frequency with which the air vibrates, the higher the pitch. The lower the frequency of air vibrations, the lower the pitch. Frequencies are measured in units called hertz. We can hear with our ears sound frequencies from 20 hertz, that's 20 vibrations a second, up to 20,000 hertz.
How do these ideas apply to music?
As I pull the bow across the string, the bow makes the string vibrate backwards and forwards very quickly. By using a strobe light, we can see the individual vibrations more clearly. All musical instruments need something to vibrate to make the sound. This loud sound is caused by my lips vibrating.
When I hit this drum gently, the vibration is very small. The polystyrene balls only just move, and the sound is quiet. The loudness of a sound depends on the size of the vibrations that made it. The size of a vibration is called its amplitude. The bigger the amplitude, the louder the sound.
But how do we hear the sound?
The air is made up of many tiny particles that surround the drum skin. When I hit the drum, the air particles next to the drum skin vibrate and collide with each other. In slow motion, you can see the vibration pass along the line of air particles. It's called a compression wave because the particles are compressed together. The vibrating particles pass the sound through the air into your ear. So the less air in the bell jar, the harder it is for the sound to be heard, until with no air at all, you can't hear a thing.
Sorry, mate.
So sound needs particles to transmit the vibrations, but they don't have to be air particles.
In fact, sound can often travel better through liquids and solids.
It gets louder.
The loudness of a sound wave depends on its amplitude. A bigger amplitude means a louder sound. The pitch of a sound depends on its frequency. A higher frequency means a higher pitch. We can hear sound from things we can't see because sound waves can travel through solid materials, are reflected from surfaces, and are diffracted round objects. Musical instruments work by setting up regular vibrations in strings, wires, skins, or tubes of air, which set the body of the instrument and then the surrounding air vibrating with the same pattern. Ultrasounds are high-frequency longitudinal waves. They have shorter wavelengths than audible sound. They're used for echo sounding and to detect shoals of fish because they travel well through liquids and solids. The reflections are picked up and timed. Medical scanning uses the same principle. There's more about waves in the physics section of the higher tier programme. That's the end of the section on waves.